we are going to look at resistors in series. When resistors are connected in series. And before I will explain that, first you have to know what a resistor is. A resistor, a resistor, a resistor is an electronic component or device that is used to oppose the flow of current. And this is the symbol of a resistor. Or you use this other one. So this is a symbol of a resistor. And a resistor has no polarity. What I mean by polarity is to say this side is the positive or this side is the negative. No. Any of the side can be positive, any of the side can be negative depending on the connection. Unlike diodes and other components that are polarized or a polarized capacitor, in which the positive side is stated and the negative side is stated. So resistor has no polarity, and these are the two symbols of a resistor. So when we say series connection, and then you have to know that the resistor offers opposition to the flow of current, and the value of the resistor is always the value of the resistance of the resistor is usually measured in what we call ohms. The value of the resistance offered to the flow of current is always measured in ohms. This is the English, this is the spelling, and this is the symbol. Okay, so let's move. When you say resistors in series, these are three resistors connected in series. Now, series connection means that the resistors are connected end to end, or you can say back to back. That means the front of this one is connected to the back of this one. The front of this one is connected to the back of this one. That's from end to end. You know, the end of this one, they bring the front of this one connected to it. The end of this one, they bring the front of this one connected to it. So that's what we mean by resistors being connected in series. Now it mustn't be that it must be in a straight line like this. It could also be something like this. It could also be something like this. This is also what? A series connection. The reason of it being a series connection is each of these resistors is being connected to the end of the other one, you know, in a straight line, in a single file. The front of this one is connected to the back of this one. The front of this one is connected to the back of this one. The front of this one is connected. That's a series connection. It doesn't matter if I still extend the length of the line. The series connection still continues. So this is also what? A series. So no matter how they turn the line or curve it and the rest of it, just check if the front of the successive resistor is connected to the back of the first one, and the process continues like that. That is when you know that you have what we call what? A series connection. So there are about 3 points that I would like you to note when we talk about resistors being connected in series. So these are the few points that we're going to take note when resistors are connected in series. The first one is this: the total or equivalent resistance is the sum of the individual resistances. That is your R1, R2. That is the total resistance. For instance, the total resistance from point A to B will be what? The summation of the individual resistance. That will be R1 plus R2 plus R3. Take for instance, if your R1 was equals to 2 ohms and your R2 was equals to 5 ohms, your R3 equals to 3 ohms. Your equivalent resistance as measured at point A to B will be what? Either you write R equivalent or you say R total will be equals to what? This plus this plus this, that's 2 plus 5 plus 3, that will be 10 ohms. So that's the first point you have to note when resistors are connected in series. The equivalent resistance of the connection will be what? The summation of the individual resistances. Then number two point you have to take note is this. Now, the same current passes through each resistor. The same current passes through each resistor. That's what we mean is, if you apply a voltage here and a current comes into this network, a current called what? I1. That means if you measure the current across R1, the same current you measure across R1 will be the same across R2, will be the same across R3. So that means the total current in this line will still be I. Assuming the current through the first resistor, assuming if you call it I1, and then current through the second resistor, you call it I2, and the current that enters the third resistor, you call it I3. What we are saying that the total current will be what? The same as the individual current. That's I total will be the same as I1, which is also equals to I2, which also equals to I3. These are knowledge and facts that has been tested and proved, experimented. So, in a series connection, the same current flows through each resistor. So, if the current that entered the circuit here was 2 amps, current is measured in ampere. If the current that enters through this line is 2 ampere, or you say 2 amps, and then you have to find the current across R1. The current across R1 will still be 2 amps. The current across R2 will still be what? 2 amps. The current across R3 will still be what? 2 amps. So that's what this second point is saying. The same current passes through each resistor. That's if they are connected in series. So let's look at the third one. The third one is that the potential difference across each resistor depend on the value of its resistance. The potential difference across each resistor depends on the value of its resistance. So what are we saying here? So what are we saying here? Now, you know what potential difference is. Potential difference is the difference in the charge accumulation between 2 points in electrical network. So now, if for a series connection, the voltage across each resistor will not be the same. It can only be the same if the value of the resistances of the resistors are the same. But if the value of the resistances are not the same, their voltage measured across each resistor will not be the same. Like the voltage that you measure between V1, the voltage that you measure between R1 will be different from the voltage that you measure, that's V2, between R2, and it will also be different from the voltage you measure across R3. You understand? So the voltages of across each resistor here will depend on the value of the resistance. So take for instance now So take for instance, we said that let's assume current of 2 amps enters through this line, and then we have seen the value of each of these resistor, and then we are to calculate the voltage across each resistor. From Ohm's law, you know that V equals to what? Current times resistance. So now for V1, that's the voltage across the first resistor, that will be the current there is 2 times the resistance there is 2, that will be equals to what? 4 volts. Then V2 will be what? 2 times 5, 10 volts. V3 will be equals to what? 3 times, 2, the current 2 times 3 to be 6 volts. So you see that the voltage across each resistor will depend on the value of the resistance. The greater the value of the resistance, the greater the voltage drop across that resistor. The greater the voltage drop across that resistor. And then the last one, number 4, the potential difference V across the whole series connection is equal to the sum of the individual potential differences across each resistor. Don't worry about the too much English there. What this thing is saying, that the equivalent voltage, or the voltage measured between point A and B, that's the total voltage in this line. Now, what will it be? The total voltage will be what? The summation of the individual voltages. That's V1 plus V2 plus V3. So in this case now, we have V1, V2, V3. That means the total voltage across point A to B will be 4 plus 10 plus 6. And that will give us what? 20 volts. So in a series network, the voltages across each resistor is different, and the total voltage across the network is the summation of the individual voltages. The same current passes through each resistors. Then the equivalent resistance is what? The summation of the individual resistors. So that is what you need to know. Okay, so let's take one small simple example to see how well we understood that. So what if I give you a simple circuit like this? 2, 3, and 4. Then here is 2 ohm, 1 ohm, 3 ohm, and 2 ohms. So now I ask you, between points X and Y, what is the equivalent resistance there? What will be your answer? First, you have to know that this is a series connection because each resistor is connected end to end, back to back. So the equivalent resistance, R equivalent or R total, will be what? Summation of the individual resistances. That will be 2 plus 1 plus 3 plus what? 2. And what would that give you? 3 plus 3, 6, 7, 8. That would be 8 ohms. Okay. And then, assuming I now tell you that I applied a voltage of 12 volts. Okay, let me not make things complex for now. Okay, so what if I say that a current of 1 amp is being sent in from that line, and what will be the voltage of each resistors? So for the first one, V1, the voltage across it, formula for voltage from Ohm's law is IR. So that will be 1 amp times 2 to give you what? 2 volts. Voltage across this other one will be 1 volt, 3 volts, 2 volts. And the equivalent voltage, V equivalent, what will it be? So suggest, what would the answer be? Answer will be 8 volts. So that's what you need to know about resistors connected in series and parallel. So the next video, you check out the next video for more examples, or you go to where we have our solution banks based on current electricity and solve more problems there. Don't forget to like and subscribe on the video, and then below on the description there, you see the link to our WhatsApp group where we can take questions individually and work on them. Thank you.